Our 2.5 notes is a quick review over a quadratic. The first thing you need to remember is the standard form of a quadratic. Quadratic functions are functions written as the form of ax squared plus bx plus c. X squared plus bx plus c, where a of course is the leading coefficient. The vertex form, on the other hand, is on the form y equal, or f of x equals a x minus h squared plus k. Now your book, if you look inside the book, you will note that they're calling this form the standard form, but this is the real standard form. Alright, on any quadratic, the value of a is very important. When you're looking at a, if a, the value of a is greater than 0, in other words, if a is positive, we know that the graph will be opening up. And if the graph opens up, it means that we have a minimum. If a is equal to, let's start with less than 0. If a is less than 0, we will know that it's opening down. And if it opens down, by the way, here's the minimum. If it opens down, we now have a maximum. And if on the other hand, a is equal to 0, we have something else. A being 0 is no longer a quadratic. So I will say not quadratic, because once a is 0, we actually have a linear function. Speaking of vertex, let's start by completing the square. And on this equation, the vertex is at hk. Always flip the sign inside the parenthesis, keep the sign of the one outside. Let's do completing the square. I will start with a very simple equation. The equation I want to start with will be f of x equals 2x squared minus 12x plus 23. I remember we mentioned something called half ball square, and I think by now you should know how to complete the square. Now, the only difference is, the first thing I will do, I can rewrite it as y equals 2 times x squared minus 6x plus 23. Half ball square will be, you will have this one to get x minus 3, the whole thing squared. The 2 will remain in front. You still got the positive 23. But if you square this number to put it on the opposite side, that will be 9. You still got to multiply by 2. In fact, you're adding 18 to this side. That's 9 times 2. But instead of adding 18 to this side, I will go ahead and subtract that 18 from here. So I will end up with 2x minus 3, the whole thing squared, and this time will be plus 5, and that's y equal, or f of x equal. It's up to you. Let's talk about the vertex. The vertex in this specific problem will be at 3, 5. Let's go ahead and think about if we have a maximum or minimum. Well, looking at the a value, a is positive. And I mentioned earlier, when a is positive, we have a minimum. The axis of symmetry is at x equals the x value, which is 3. So this is your axis of symmetry. Let's talk about the intercept now. We have two types of intercept. I can talk about the x-intercept and the y-intercept. So I have x-intercept and I also have y-intercept. For x-intercept, the best way to work with x-intercept is to set y equal to 0. Set y equal 0. Compared to y-intercept, you will set x equal 0. So if I wanted to find the x-intercept of the equation we had earlier here, I will set it equal to 0. In other words, I will have 0 is equal to 2 times x minus 3 squared plus 5. Well, I will subtract 5 from both sides and divide by 2 to get negative 5 over 2. is equal to, if I find on this side, I will have x minus 3 squared. Now I will find the square root on both sides, and the fact that this is negative is going to give me imaginary. And it's giving me imaginary because I will end up with the square root of a negative. Therefore, I have no x-intercept. Let's do the same thing for y. For y-intercept, I will plug in 0 for x. That will be y equals 2 times 0 minus 3, the whole thing squared, plus 5. Well, 0 minus 3 is 3. 3 squared is 9. 9 times 2 is 18. 18 plus 5 will be 23. So our y-intercept is at 23. If I want to graph this, this is how it look like. I will start by graphing the vertex, and the vertex is at 3, 5. So 1, 2, 3. 1, 2, 3, 4, 5. Here's my vertex, and I know it opens up, and I know that my y-intercept is at 23. So I assume this point is 23, and you will do this, going to the point 23 on y. All right, let's do one example. The example I want us to work on is f of x is equal to negative 2x squared plus 4x plus, what should we do, 4? Why not? Plus 4. All right, the first thing I will do is complete the square. So this is equal to negative 2 times x squared, actually minus 2x plus 4. That will be equal to negative 2 times x minus 1, the whole thing squared, plus 4. Normally, I should add 1 squared times negative 2 to this side, meaning a negative number. So all I need to do here is actually add a positive 2. This positive 2 is because normally I would have done negative 1 squared times negative 2, giving me negative 2. But negative 2 on this side would be a positive 2 on the opposite side. So I can summarize this as f of x is equal to negative 2 times x minus 1 squared plus 6. From here, I can answer a few questions, such as the vertex. The vertex is at 1, 6. And this vertex, because it's negative here, I know it's a maximum. That's not it. Not only I know it's a maximum, I also know that my axis of symmetry is at x equal 1. I don't know if we need to write it, but let's do axis of symmetry is at x equal 1. From here, I will look for my x-intercept. To find my x-intercept, I will set y equal to 0. So I will say 0 is equal to negative 2 times x minus 6, the whole thing squared, plus 6. And if I solve this one, I'll go ahead and put 0 on the right side to make it easier. I'll move the 6 to this side and divide by negative 2 to get x minus 6 squared is equal to 6 over 2, which is 3. So x minus 6 is equal to plus or minus the square root of 3. And from here, where did I get the 6 from? It's supposed to be 1. All this is 1. My fault. So I'll go ahead and add 1 to say x is equal to 1 plus or minus square root of 3. Those are my two x-intercepts. Let's do the y-intercept now. For the y-intercept, I will say y is equal to negative 2 times, I'll plug in 0 for x, 0 minus 1 squared plus 6. So if I solve this one, this is 1. 1 squared is 1 times negative 2 is negative 2 plus 6, I get 4. So my y-intercept is at 0, 4. From here, you can graph it. To graph it, I start with my vertex. The vertex is at 1, 6. 1, I assume this is 6. My y-intercept is at 0, 4. So if this is 6, this is 3. 4 will be somewhere here. So this is my y-intercept. Vertex here, y-intercept here. My x-axis is 1 plus square root of 3, 1 minus square root of 3. Well, the graph will look like this. it will come and cross somewhere here and cross here. Knowing that these 2 points, this is the 1 minus square root of 3, and this is 1 plus square root of 3. This point is at 4, this is 1, this is 6. And of course, arrow on both sides. The domain of this function is from negative infinity to infinity, but the range of this function starts, of course, at from negative infinity and ends at 6. Bracket at 6, parenthesis at negative infinity. All right, what about, let's talk about a few things. Quadratic, we always have either one minimum or one maximum, and the minimum or maximum is the vertex. You need to remember polynomials can have more than one local minimum or maximum. Think about a cubic function. Cubic function may look like this. Here we have a local maximum here, a local minimum here. So it's not always the same as quadratic. And to find that, you will use the second trace on your calculator to get that maximum.